Hi, Todd Day from Tech Ops Training. Today I want to talk about aligning the ADARUs on the 737NG. Do the alignment on the DC power, so make sure your battery's in good shape. We got our battery switch on, external power is applied to the airplane, and we don't need emergency. You don't have to stop in the align position. You can go straight to align and right in the nav with both switches. Notice that we get an on DC light here as it goes into a turn on self check. And once we have the align light, we're operational because this really makes it the easiest way to give it present position on the aircraft. We're starting with an init ref. So what I want to do is I'm going to hit the index button here. Once I select index, we go to position. And position gives us these boxes here. We need these boxes here. This is where our information is going to go.
Check. It is also part of an ETOPS procedure for an ETOPS aircraft departing on an ETOPS flight. There are two temperature criteria to be concerned about when it comes to checking tire pressure and servicing a tire if needed. Those two temperature criteria are cold and not cold. Cold is defined as temperature when the wheel assembly being at the same temperature as the ambient. In order to check and service the wheel, I went to the tool room and grabbed two calibrated pressure service and gauge assemblies. I also grabbed a small bore adapter and a big bore adapter for a calibrated pressure gauge. This particular servicing gauge has a big bore adapter attached to it. For the Boeing 737-900, the target pressure for the main tire is 225 psig, and according to the reading right now, the pressure is low. We're currently reading 220 psi, which is 5 pounds less than where it should be. Now we need to service the wheel assembly with nitrogen. When properly attached, stand away from the projectile zone and monitor the gauge while servicing the wheel. Service the wheel assembly until you have reached the service limit, then disconnect the servicing gauge.
Advancing the thrust levers is similar to pushing an accelerator in a car. You advance them, move a resolver, which sends an electrical signal to the Engine Electronic Control, or EEC. The EEC takes the thrust lever input, along with a number of other inputs, and uses this to control the thrust of the engine. Now let's take a look at the thrust reversers. A mechanical lock called an interlock latch prevents the reverse thrust levers from being operated while the thrust levers are at any position other than idle. With the thrust reversers at the idle position, the reverse thrust levers can now be pulled back. If electrical and hydraulic power is available, this will cause the thrust reverser to deploy. This will happen whether the engine is running or not. All we've done at this point is deploy the thrust reverser. In order for the crew to use the thrust reversers to slow the airplane, they about safety. The 737 has predictive wind shear. Simply advancing the thrust levers can cause the weather radar to come on. Make sure the appropriate circuit breakers are pulled. If the EEC is not powered, there will be no flight deck indication that the thrust reverser has deployed. Also keep in mind that even with the A and B hydraulic systems off, the thrust reversers could still be actuated by the standby 737NG. Now, if you've been around the aviation industry long enough to have worked on some of the earlier generation 737s, you might have actually used something like this to lock out the counterbalance on the cargo door. And this is something. Okay, the first thing I'm going to do is remove the nut and washer. And that came off fairly easily. So I'll go ahead and pull that off. And of course, right away, it's always a good practice, put it right in a parted guide pin that you'll see underneath. Okay, and we'll go ahead and put that in our parts bag also, and tie that right here to make sure that we don't lose it. Right now at this point,
I'm on the left side of the aircraft, and I get a few questions from a few folks out in the operation about this drain mast here on the left side of the aircraft. So we're going to talk about that. APU shroud on the top, hydraulic drain on the bottom. If you're doing your walk around and you see any fluid leaking out of any one of those holes, you're going to have to take some corrective action. With the top one, the APU drain shroud, if you see fluid coming out of that, it's going to be fuel. What you're going to have to do is you're probably going to have to depanel the cargo bay and look at that APU fuel line. The shroud surrounds that fuel line so that if that line ruptures or has a leak, it's going to come out of there. So follow your maintenance manual procedures. The bottom hole, the hydraulic drain, is typically going to be reserved if you have a situation where you overfill your hydraulics. The fluid has to go somewhere, it's going to come out of that drain. Either way, look into the FIM and the maintenance manual and work it. For the hydraulics in particular, maybe you've serviced the hydraulics with the flaps down, out of configuration. So either one of those two holes, be careful and follow the maintenance manual. Thanks for watching.
The following tools are required for this task from the tool room: a SPL-2417 thrust reverser opening hand pump, 2 SPL-2431 thrust reverser actuator lock assemblies, and the SPL-2434 thrust reverser C-duct halves latching tool. Disengage the 6 latches along the bottom center line of the thrust reverser. Disengage the latches in sequence from the aft latch number 6 to the forward latch number 1. The filter on the hand pump hose is out of the way on the moving thrust reverser. Operate the hand pump to pump oil into the opening actuator to lift the thrust reverser. As the reverser approaches the full open position, listen for the click sound on the lock collar. Make sure that the word locked shows on the bottom of the extended piston and that you can see the red band on the actuator rod. Install the actuator safety assembly on the extended piston rod. Open the return valve on the hand pump to let the weight of the thrust reverser be held by the locked opening actuator. Immediately close the return valve on the hand pump after the thrust reverser is lowered and the weight is held by the locked opening.
Hi, Todd Day from Tech Ops Training. Today we're over here in Bay 11 at the hangar and we want to discuss the pneumatic system on the 737. Chapter 36 has traditionally been a problem with us as far as being a high driver on the aircraft, and a lot of times we're getting pneumatic bleed trips due to high temperatures. Anytime you're up under here, make sure you use your safety items and locks. It's imperative. We don't want to get crushed when we're under here. This is 475 pounds. It would do a lot of damage to you should that happen. So from the left side of the engine, let's go up and look at the components that we're going to be dealing with. So underneath the reverser cowl here, to look at which ultimately ends up in a line being broken. I'll show you an example of that in just a minute. So one of the things that we want to do is when we're doing the installation of these components, whether it be the pre-cooler control valve, the bar, the high stage, regulator, the PRSOV, the high stage valve, is get your component loosely put in place. In other words, get the valve installed, put the clamp on, but don't tighten anything down. The next step would be to go ahead and put all of these solid lines in place and then torque them down using the proper anti-seize. It's important that you use the anti-seize because this is an extremely hot area up under here, and we could actually fuse these lines together. So that being said, get all your muscle lines in, or any of these stainless steel solid lines that you see throughout the system here. Get these all firmly connected, and then after that's all done, final install your clamps on whatever component it is you're changing. That'll prevent you from having problems in the future.
Items needed: full face crew mask, lint-free cloth, deionized/distilled water, 100% isopropyl alcohol. Note: lens polishing and scratch repair are not addressed in this training video. Step 1. Using a clean lint-free cloth and deionized water, clean the lens assembly on both the inside and outside surfaces. Note: use a significant amount of 100% pure isopropyl alcohol to remove all debris and avoid recontamination by using clean portions of the cloth during cleaning. When the cleaning is complete, the lens assembly should be free from debris and available to use immediately.
Hi, Todd Day from Tech Ops Training. In this video, I want to show you how to start the APU using the battery power on the aircraft. So let's get started. First thing that we need to do when we start the APU is we need to turn the battery on and verify that we actually have good voltage. So the first thing we do, battery switch to the on position. In the battery position, we'll notice that we actually have good voltage. The APU suction feeds off of the left tank. So when we start the APU, it's imperative that we make sure that we have a minimum of 500 pounds in the left tank. That's our first button. Then I want to go to the APU. Once I select APU, it goes into an initialization for the APU, and my menu pops up. And in this case, what I'm really worried about is input monitoring. So I'm going to select input monitoring. And from input monitoring, you'll notice that I actually have 4 pages of real-time information that we can actually monitor during the actual start. So what we're going to do is we're going to go through and do the start here. You'd be able to see speed, EGT, and various other things like fuel flow. You could actually see when fuel is going to go in there. That should coincide with an EGT rise. So at this point, I'm going to go ahead and initiate the start, and I want you to kind of watch these indications as we do the start. Okay, to start the APU on the overhead panel, we make sure that we have no lights, no low oil pressure faults or overspeeds. And to get the process started, we simply move this switch momentarily to the start position and then release it to on. Now we notice that our EGT gauge started to power up. We have a low oil pressure light. That's what we were looking for. That light should go out at approximately 30%. So, right now the fuel valve is opening in the wheel well, and the door opened. Once the door opened, the starter and ignition engaged, and now, as you can see, fuel is going in there. At about 30 or so percent, the low oil pressure light's going to go out, just like that, and the airplane is now on its way to stabilizing. So this is going through all the various processes, and we'll know that we're ready to do work on the APU, or let the APU do work for us, when we hit 95%. So what I'm going to look for is I want a APU Gen Off bus blue light to illuminate, which it just did. There's my 95%. You notice my EGT is now stabilizing. Being that we're maintenance, it's a good idea to wait a minute or two before we actually apply external power to the airplane, or we actually put a pneumatic load on the airplane. That's just to let the APU kind of warm up and stabilize a little bit before we actually start loading it up. Okay, now that we have our blue generator off bus light, the next order of business we want to do is just move the switch to the on position. Now when I move my switch to the on position, power comes up through the light, gives me a source for my left side, and both of my Now we're going to start working on the hub portion of the fan blade change. In this position, it's kind of nice to know again where your number one blade is. If you look on this hub here, you'll see a little dimple, and that's right there near our offset hole. Again, we got bigger ED here and less ED here, so that's your offset hole. There is a dimple to tell you that this is our number one blade. We're working on taking the chiclets or spacers out here. What do we have to be careful of? Because we know that this is an extremely expensive part. What could the mechanic do wrong at this point that could scrap this hub?
Well, a lot of times what guys will do is they'll use a screwdriver and pry up under here and try to pry the chiclet out from the top or the bottom. If you go over the top, you're into the booster spool.
You're in this hub.
And up in here, you could damage it very easily. So we have a tool. Part number is 856 A2691G01. It's a small pair of pliers with almost like a alligator jaw on the end, and they work really well for pulling the chiclets out. So I'll go ahead and start with that. We're going to pull these guys out. This is where things get critical. This is the proper tool for removing them. It makes it nice and easy. There's a hole in the bottom, and this spacer is shaped like a banana. So when you pull it out, you don't want to pull it straight out. You want to kind of pull it and follow the curve of the spacer. Now, if you try to use a screwdriver or a booger hook or something of that nature, is when you can scratch up these faces in here and cause all kind of damage to an area that's not allowed any damage.
Now, is it important to keep those keyed, or are they all the same length?
They're all the same length, same weight. They don't have to be numbered. They can come in and go out in any order.
So only the fan blades is what matters.
Only the fan blades matter. All right, you're going to hook the platform in the back. Put the pin in the front. And line that up. Tighten your spool down, and it's going to hold your platform like that.
It's holding at the back edge.
It's holding at the back edge here.
And in the pin on the front.
And then the pin in the front.
Okay. And what do they use to I guess there's a slide.
Now next you have the other piece. This piece right here will thread in. Once this piece is threaded in fully, then you have your slide hammer. And the slide hammer will thread on the end of that piece. And that point you can easily just pull it out.
Okay, should we follow the same rule as the spacer? It's shaped like a banana, so we got to.
Yes, it's going to come out at an angle slightly, and it's going to turn as you pull it out also.
Okay, perfect.
With these, soon as you pop off of the tabs in the back, if you turn it up and sideways, it comes out best. And that is all of our platforms. All right, now we're at the final step of our fan blade removal for your lube job that you're going to be doing. The next step is going to be the actual fan blade removal. As you can see, these actually have shims on them because it is a broach disc. If you see the writing on the disc, it will tell you shims and spacers required. The most critical thing to do at this point is make sure your blades are properly marked, identified, and stored in your rack or however you're storing them in order, because this is where your balance comes into play. Rounded edges and things of that nature, it'd be really hard unless you were to drop it and damage the blade itself or the fan frame. And this is number 5 blade. If you notice on the hub, if you look closely, we'll show it later in the video, number 1 slot and number 5 slot are both marked to make sure you install them in the proper direction when you're putting them back in.
Not a big deal that the hub is actually
No,
rebalancing itself.
it just balances as you pull a blade. It just recenters.
Can you show real closely how to pull the shim off? Like how
Yes.
this works? Walk up to the camera.
All right. The shim just slips right over the dovetail on the end, just like that. It's open, slotted, and very easy to pull on and off. Yeah.
Minimum Equipment List 78-00-01. Thrust Reverser Systems. Dispatch approval is required. Bite the EAU and record any faults in the aircraft logbook before thrust reverser deactivation. The deactivation pins are located in the landing gear pin pouch. Deactivate and secure the affected thrust reverser using the following procedures. Note: there are 2 procedures that can be used to make sure that the sync locks are in the lock position. Procedure 1. The first one is used if the thrust reversers can be stowed and deployed with hydraulic power. Procedure 2. The second is used if the thrust reverser will not stow or deploy with hydraulic power. Procedure 1. Thrust reversers that will deploy and stow with hydraulic power perform these steps to make sure that the sync locks will lock. Applicable engine. Make sure that the start lever is in the cutoff position. Thrust lever is in the idle position. Reverser thrust lever is forward and down in the retract or stow position. Warning: make sure persons and equipment are clear of all control surfaces before you supply hydraulic power. Ailerons, rudders, elevators, flaps, spoilers, and the thrust reversers can move quickly when you supply hydraulic power. This can cause injury to persons and damage to equipment. Pressurize applicable hydraulic system. Hydraulic System A, number 1 engine. Hydraulic System B, number 2 engine. Warning: make sure that all persons and equipment are clear of the area aft of the applicable thrust reverser. Injury to persons and damage to equipment can occur. Slowly move the applicable reverse thrust lever up and aft to extend or deploy the thrust reverser. Pull and secure the applicable sync lock circuit breaker. Engine number 1, P18-2 panel. Engine 1 thrust reverser sync lock. Engine number 2, P6-2 panel. Engine 2 thrust reverser sync lock. To verify that there is no power to the sync lock. Gain access to the EAU located in the Electronics Equipment Bay E3-2 shelf. Push and hold the TR stow fault switch for the applicable engine. Make sure that all of the lights come on for approximately 1 second. Take note of these sync lock power lights for the applicable engine. V148 left sleeve sync lock power. V150 right sleeve sync lock power. Release the TR stow fault switch. Close the electronic equipment bay access door. If sync lock power lights go off, pull and secure the applicable circuit breaker. Engine 1, install 2 deactivation pins in the left and 2 deactivation pins in the right thrust reverser sleeves on the applicable engine. Make sure that the deactivation pins go through deactivation pinholes and into the aft cascade support ring. Tighten the deactivation pins to approximately 152 to 168 pound-inches. Note: you must install 2 deactivation pins in each of the thrust reverser sleeves. The upper deactivation pin protrudes approximately 1.75 inches. The lower deactivation pin protrudes approximately 0.50 inches from the outer cowl. Lock wire the reverse thrust lever to the applicable forward thrust lever. Disconnect the electrical connectors from the sync locks on the left and right thrust reversers on the applicable engine. Protect the electrical connectors. Left thrust reverser, electrical connector D1008, right thrust reverser, electrical connector D1016. Secure the electrical connectors to the thrust reverser with tie wraps or tape. Install 2 deactivation pins in the